So in this video, we're going to talk about how the squash bee model works, and hopefully if you're watching this video, you've seen the model on the website and have played around with it a little bit. So to talk about how it works, we're going to first imagine an agricultural landscape. And this landscape is going to be totally empty, but we're going to fill it with 100 parcels, with 100 field parcels that are all the same size. And we're going to add squash fields to 3 of these parcels, and let's just say these squash fields bloom in even years. And then we're going to add 3 more squash fields that bloom in odd years. So these green boxes just show where the previous fields were. And we're just going to toggle back and forth, looking at fields in even years, and then fields in odd years. And it's always the same 6 parcels that we're growing squash in. It's just some are grown in even years and some are grown in odd years. So again, we have even years and odd years. And then what we can do is add numbers to each of these parcels to keep track of where they're located. And if we switch out these pumpkin images with yellow boxes, we end up seeing something similar to the top chart that comes with the output of the model. And now we can also apply something like a deep till to these parcels, to all of the parcels, to see how that impacts the squash bees we're going to add to the parcels. Or we can choose to run the model without any tilling and have all the parcels free from tilling. The other thing we can do is decide how we want the parcels to be set up. So we can have them clustered near each other, so squash is always near each other across years or far apart from each other, or we can apply a pattern that's completely random. So before we move on, let's remind ourselves some things about squash bees. These bees are specialist bees that only collect pollen from squash, pumpkin, and gourds, and they prefer to nest under the vines of these crops. In the spring, females and males will emerge, find each other, mate, and then females will go to build a nest under squash vines. She'll dig out a tunnel and put a little cell at the end of that tunnel, put pollen in that cell, lay an egg on top of that pollen. The egg will hatch into a larva and eat up all of that pollen, and then overwinter in a papery cocoon as a prepupa. In the spring, that prepupa will pupate into a pupa, and then that pupa will eventually emerge as an adult in the spring. However, in the meantime, the grower will have converted that squash field into a tomato field, let's say, and so when that pupa emerges as an adult, it will have to find a new squash field in order to survive. And so a squash bee to-do list, life to-do list, might look something like this. First, survive tilling, and then if that's completed, emerge from the nest. Once they've emerged from the nest, they need to find squash, and at that point, they'll hopefully find a mate, and then mate, and be able to produce offspring, and that process will repeat generation after generation. So this is the list that we had in mind when we built the model. And if we go back to that pretend agricultural landscape that we were talking about before and zoom into one of those yellow fields, which we can say is a blooming squash field this year, we can see 2 bees moving into that yellow field from a field that was in bloom last year, depicted in green. So those bees will move into the field, they'll lay a certain number of eggs, and then at the end of the season, they'll die. Those eggs will overwinter in the field and survive unless tilling comes through, in which case some proportion of those eggs will die. In the spring, new bees will emerge from those nesting sites and look for a new squash field, here depicted in yellow. But if there is no squash field nearby, then those bees will die. And these are all the things that are going on in the background of the model. And so every time you hit simulate, we can track how the squash bee populations in the region grow over time as a function of where the field is located and whether those fields are tilled or not. And that's how this model works. So hopefully you'll go back to the website and try out the model a little bit more. and enjoy learning a little bit about squash peas. Thanks for listening.